So as I said, today I will do certain empirical exercises, but I want to emphasize that the exam will not have empirical questions. So this is completely for homeworks. And of course, those homeworks are really, really important for understanding what we learn in a better. So I will now open my R Studio. You can also go and download from the CUNY Blackboard. You can download certain data files and also um, R script that I uploaded on the CUNY Blackboard, which is in the class week 15's folder. And there you will see R script and data. You can download all of those and you can synchronously follow and you can do this together. But if not, that's okay too, because you'll be able to, you'll have this recording and you'll be able to replicate everything yourself.
Is this data same as we used before, or we should download new one?
Even I will download the newest one because, okay, first let's try to download these ones, and if we have some like face certain issues that we may face, then I will have to like download new ones from them. Because as you guys know, Pearson changes numbers, so I'm not sure if we want to get numbers that are correct. So okay, so but for now, please download the R script and also these data sets, and then let's see how it goes. Okay, so let me now open this R Studio, and let me share my screen. So again, guys, this you see the blue screen, right?
Yes.
Yeah.
Good. So this color, this theme, I have this blue theme for the R Studio, but that's okay. You can have whatever color you like. So don't get confused if you don't have this blue screen. So, okay, so you see this, that's perfect. Now let me open, first of all, the first problem is chapter 5, exercise 1.
So, Professor, are you going to show us like how the question on Pearson from your screen and then solve it, or are we just going to do it like this?
I'm just opening it and I will show you guys both these.
Okay. All right.
So we're doing chapter 5 first.
That's it. Okay, so I opened it and now I will share the screen. So what do you guys see right now?
Blue screen, the R Studio.
Okay, so you only see that. How about now?
Split
Yeah, we should
screen,
both.
I see both.
That's perfect. Okay, so we make it smaller. Okay, so what I will do is that I will download this data once again, because you know I saw that like the numbers in some problems do not coincide, like they are very, very close, but they're still different. So I want to say some things about that. First, let me put this in the folder. Okay. So now what I will do is that first I don't need this. And so now I will download the dataset from this problem in Excel format. And this is, guys, please note, this is in XLSX extension. Okay, so which means if you if you right click on the Excel file that you downloaded, you'll see that the extension is XLAX. Let me show you that. Do you guys see? So that's the extension, and that's important because we will need to indicate that properly in R. So now let me see what is the name I gave to this Excel document, Excel file. I gave it the name of Data Chapter 5, Question 1. So let me rename it. Okay, so now I renamed it. So that's our data. Let's open this data.
Professor?
Yes.
So when you download an Excel file, does it automatically show up on RStudio?
No, when you download it, in my case, it falls in the downloads.
Because I saw that when you downloaded this Excel file from Pearson, it
Yeah.
showed up on RStudio. I just
No,
want to
no,
know if
it didn't. It's something else. It's from the previous work. So
okay.
yeah. So do you now see the Excel file?
Yeah.
Good, perfect. So what I want is that, guys, we need to delete this first row because that will cause problems. Like the RStudio will not be able to read the data properly. So I have to delete this row. And then we have this first row, which is like the titles, labels, perfect, and then we have all this data. So that's perfect. So we are ready to go. How many observations do we have here? Let's just double check. We have 100 because the last one is 101. So let's save it and then close it. Now let me share both this one and RStudio. Now I should be able to share both here. So first, guys, what we do is the following. So you see this stuff here, right, in the global environment. So we don't really need this because this is like from my previous work, from the previous session. So like I was using Garden yesterday, so then that's left from yesterday. So what I will do first is then that I will just use this command, which will clear this global environment. There's nothing now. So first, what we need to do is that we need to, if you guys do not have already installed these packages, AER stands for applied econometrics in R, and then there are certain other packages which you can just, you see this, right?
Yes.
Right? If you write anything, if you write here, there, let's say, stargazer, that will give you guys more information. So stargazer. So then you click here, and then it gives you information what it is about. So all these examples and stuff. So this is the package that we will be using, but you can, if you can get more information using this help here. Okay, so now I have already installed these packages in my RStudios R, so I don't really need to reinstall them. But what I need to do is that we have to set our directory. So we have to indicate a folder, or in other words, a directory where our Excel files are, where our R script is. And in my case, it is in downloads. So how do we set the directory? We go to session, and then we go to set working directory, and then we go to, and then we choose directory, and here I have to choose downloads because my directory is downloads, because my Excel files, the data file, and the R script piece are located there. So I have to indicate downloads. And that's all. So as you see here, the directory is already set. We are good to go. You don't need to run this command because we already set the directory from this tab session. And then we have to open these two libraries. First is library AER, which is since we are working with some econometric models, I mean the regression models. Lots of good things are in the applied econometrics in R package. But even though we have installed that package, we need to open that package so that we are able to do certain estimations, right? So, okay, then I will click, select this, and then run. That will open this applied econometrics in our AER package. And then I also need to open the library of read Excel. Read Excel, that stands for opening Excel files in R. And now we are ready to start solving our problem. Now, okay, so first we need to open our data. If you guys remember, I named the data set, I downloaded as data chapter 5 /Q1, okay? But as I said, the extension was, as we saw, XLSX, right? So sometimes it is just XLS. So if you don't do it properly, then that messes up things. So let us open. So this is like this, data earnings, that's the name I am giving to the data. Now you don't see anything in the environment, right? It says environment is empty. But when you run this command line 17, that will change, because then you have these data earnings, which has 100 observations. There are 3 variables, but okay, then that's fine, but we want to see the data. So then what you can do is that you can just run this command line, which is view data earnings. That's the name you gave to, sorry, I clicked on something wrong. So that's the name we gave us to the data set. So we will now see our data set in R. And that's our data set. And then you have to check if everything is good. Okay, so we have how many observations? We have 100 observations. That's perfect. Looks like we opened the data set pretty well. Now we will do certain problems. Now, the first question is, run a regression of earnings on height. Okay, let's do it. We can do it like so, using this command line 20. Right? LM stands for linear model. Data is in this case we have to indicate our data, which is data earnings, and the linear model, that's the name I gave to my model. And all the estimates will be saved in linear model. So let me run this, and all the estimates are saved in linear model, and let us summarize summary linear model. And we get this output, right? We have the estimates for intercept, which is this. We have estimate for the slope parameter that stands in front of height, which is this one. And then we have estimated standard deviations, t-value, t-statistics, which is like in other words, it is also known by t-value, t-statistic. And then we have these p-values, right, for both. And also we have residual standard error. We know that there is 98 degrees of freedom. Why? Because what is degrees of freedom? It is n minus k minus 1. K here is 1. 1 stands for the intercept, so n minus 2 is 98. We have r squared. We also have adjusted r squared. And then we have f statistic. And we have p-value for the f statistic. And that's it, guys. But the thing is, these numbers here are not correct. The only correct numbers are this one and that one, because as I said, very often and very likely, we always have, very likely, almost always, we have heteroscedasticity in the disturbance. So, okay, then we have to make a correction for that. The next question, okay, is the estimated slope statistically significant? And we see the estimated slope is here. And we see the p-value is very high. What would you guys conclude? Is the estimated slope statistically significant? No, because p-value is like very high, because it is greater than even 0.10, which means that we fail to reject it. If it was less than 0.10, we would at least by 10%, 90% confidence or 10% significance level, we would be able to say that we reject H null. But we don't, because p-value is really high, so we fail to reject H null. In this case, that the coefficient of the height is equal to 0. We fail to reject that. So yeah, so it's not statistically significant, not. And that's why we have no there. And the next question is, construct a 95% confidence interval for the slope coefficient. Now, guys, are you guys with me? Because I want to say something here.
Yeah.
So so first let us try to do this here. How can we do it? We can use coef test. That's a function that was worked out by someone. And as I said before, there are certain ways of correcting for heteroscedasticity, and HC1 is one of them. All of them are different, but very similar to each other, the results. So if we click here and if we choose type HC1, because as I said, there are other types too, HC1, HC2, HCC stands for heteroscedasticity corrected. H heteroscedasticity, C corrected. Standard array 1, 2, 3, 4, 5. Those stand for these different ways of correcting heteroscedasticity, right, in the disturbance terminal. I am using this HC1 type of correction for this heteroscedastic disturbance, but there are others. I've tried all of them, so the answer is not what we have here. So, but very similar. So what do we have here? We have new estimation. These numbers, guys, the estimated parameters are the same as you see, guys, right? But there will be difference in the estimated standard deviations. Do you guys see that? And that's how it should be, because very often we have heteroscedastic disturbance.
That's right.
Yeah.
I think I should have asked you this earlier, but when you first opened R, you had the Stargazer and the AER.
Yes.
I think somewhere in the top. So we have to have that built in, right?
You have to have all of this, yes.
Okay, and this was already posted on Blackboard before?
Yeah, I already have these previous codes, R scripts on the CUNY Blackboard. I think I had those comments there, but if you don't have these packages installed, it does not hard to do it. Even if you have it installed, have them installed in your computer, in your R, it doesn't hard to do it again. That just takes a few moments and that's it. You can use this code. You don't really need to go back and see what we had before because this is like has everything.
I just wanted to know where I could find that, like what class.
I'm not sure. So then I have to go. I will tell you later, but
Yeah, okay.
I think it's better if you go on. But it should be like maybe class 7, 8. Please check like around 10.
I mean, that's fine. You could probably email us later, but
Yeah,
that's
but I mean, this R script is pretty comprehensive. We don't really need to go back and see other codes because even if you don't, this package gives you this script gives you pretty much everything that you need. Okay, this curve test gives us what? That gave us these numbers, right? But then we have to construct the confidence interval, right? So how do we do it? Okay, forget about this. These are like I was playing with certain things, but didn't really. For example, this Q norm. This gives us norm stands for normal distribution, and Q norm is a function that gives us the critical value from the standard normal distribution for two-tailed test at 5% significance level. Similarly, QT is the critical value from the student T distribution. Okay, what do we have here, guys? Here we have this lower and upper bounds of the confidence in 95% confidence interval, right? So do you see this? 611.95. Oh, the numbers have now changed.
yeah.
See, every time the numbers are getting changed. So this is because I downloaded new data. Probably that's the reason, guys. So
I can't even run that. It just keeps popping the errors.
you cannot run it?
No, I try running and it's just popping errors, and I downloaded everything. Yeah, I'll fix it later, I guess.
Yes, please. So it shouldn't give you any errors if you are following this. So, okay. And now I have to minus 1.96 times this, right? That's the estimated standard deviation for slope. Okay, so do you guys think this is correct?
Yes.
I would not agree with you, Jahid, because this 1 point, what is the number of observations here?
Oh, it's less than 120.
100, right? And yeah, it's less than 120. That's right. So I do not think that 1.96 is correct. So I think we need to use student T distribution here. So that's why I have this QT here, and this 98 stands for the degrees of freedom. So what is our degrees of freedom? 98, right? Because we have 100 observations and then -1 for one slope and then -1 for the intercept. So we're 98. So that means that's minus 1.98, right? I think that's proper. That's more appropriate. So you can even okay, we can then do this. Okay, this one here, and then do this. Let's see what we get. Minus 946.07 which is different from this, right? So okay, let's see what this gives us. 96. See, this is correct. Do you see Mati and Jahid? Are you guys here?
Yes.
So this is exactly right? Do you see that it exactly coincides? Like not exactly, but very similar.
Yeah, yeah.
But the thing is, this is incorrect. So I just want to highlight and emphasize, guys, that, you know, this, I'm not saying that Pearson is like, this book is bad. I'm not saying anything like that. I'm just saying that you need to be critical thinkers, right? What would you think that this is right? I personally don't, because even, I mean, I don't think 1.96 here is appropriate. Do you see what I mean?
Yeah, because we have less than 120 observations, so we have to use a different.
Which means we don't
table.
have large enough sample, right? So because of that, we have to use, at least I would use I would pick the critical value, appropriate critical value from the student T distribution, guys. Okay, so which is, I would do this. That would be the critical value. And then the right answer, I would say more precise answer would be, let me just copy this here. I think more precise answer, what did I do? Is this. Okay, I think that's the right answer, if you ask me. But that doesn't coincide with the answer which we have here in the Pearson's answers, right? So that's bad. But okay, so then you have to use 1.96. But I'm just saying that beware. Know that, you know, this is not like an appropriate answer. Do you see what I mean?
Yes.
So okay, so let's do what we can do, and then we need to also find the upper bound, and that will probably coincide with this one. But what I also, guys, want to highlight, so even if you enter this number, guys, even if you enter this number, the answer will be wrong. Because see, the third decimal is 2, and the third decimal here is 5. Do you see what I mean?
Yes. So what's the difference?
No, between these two, right?
No, like, what's the difference? What do they want us to use to get to point?
They want you to use this expression and do this in Excel, I think. This is because of rounding, and I will tell you why is this the case. So when you guys do this, like when you run a linear model, and then when you do this coef test, right, you see that you get standard errors up to 2 decimal. Do you see what I have, what we have here? And you get these estimated coefficients up to 2 decimal, right?
Yeah.
When they ask you to get answers up to 3 decimal, then you need more, then you need additional decimal here, right? Otherwise, you would not be able to get the correct answer. Do you agree with me? Don't take my answers like, think about it. So I want to get answers that are precise up to 3rd decimal, but I am taking this, for example, do you see I highlighted 610.12?
Yes.
I need the 3rd decimal, otherwise how can I give you an answer that is precise up to 3rd decimal?
How would you get that third decimal?
So the thing is, Jahid, I think you need to use this formula.
Oh,
The formulas they give in the help, right? And
So would we get?
What?
I was gonna ask if we were to input those numbers from R to Pearson, would we get the question wrong?
Yeah, so the thing. Let me try, okay? Because I don't know. The thing is, because I mean, this one. Look at this. The third decimal is incorrect, right?
Yeah. Yeah.
I think that would be treated as incorrect.
Okay, I see.
Let me try. I don't know, but this. I think that would. I think Pearson, because they say that up to 3 decimal. So what I want to say, guys, is that these codes are correct. Okay, so you can use them freely in your works. Okay, you don't have to worry about like, is this correct? This is correct. Simply, this person is set up so the answers are inputted like sometimes very weirdly, because they sometimes ask like up to 4 decimal, up to 3/3 decimal. That's fine, but I mean, they want you guys to do things like in just one particular way, right? And which is like they want you to use this expression or to find this estimated standard deviation for beta 1 hat. Here should be beta 1 hat.
Professor?
Yeah.
So these answers you got, did you do them on R Studio or on Excel? The answers you got on Pearson right here.
No, this is like Pearson allows me to see the answers. Like the instructors, they allow instructors to see the answers. But I just wanted to say that, see how precise our answers are. Our answers are precise. The third decimal is different. Third decimal is different because we don't have like the estimations we get in R, guys, are not, do not have third decimal. Do you see that?
Yeah.
That's why, and we are using those, right? So 610.12. Where is it? So this 610.12 minus 1.96 times 784.19, and then we get the answer. Okay, that's great. We get the answer, but that will not be precise up to third decimal. Do you see what I mean? Yeah. It will be precise up to the second decimal, but not the third. The third one will be different. So that's why you will have to use this expression. And I'll give you guys hints how to do it, because if you go like this, like if you do this, all of these steps, we won't be able to finish like for hours. So I will just give you hints how to do it. So do you really need it? You need it to complete your homeworks, but in real life, this would be absolutely enough. Do you see what I mean? Like what this answer would be good, but also I highlighted, I emphasized that this 1.96 I don't think is appropriate, because the number of observations is 100, which is less than 120. We should be using, I believe, the critical value from the student t-distribution with the 98 degrees of freedom, because we have one slope and one intercept, so 100 minus 1 and minus 1 is a 98. So guys, let's do this in Excel. Let me open Excel. And let me share the screen with you guys. Now you see Excel, right?
Yeah.
So
Yes.
now let's first, great. So now let's first run regression of earnings on high. I will use data analysis, and then I will choose the regression here. Okay, and then we need to input by range, which is earnings. Let's do it right now. And then we will input X range. We need to be like very careful because when you have to do all these like calculations, then you have to be careful because if you miss something, then you get the wrong answer. And that's the estimate. Oh, what's that? Okay, doesn't it did not name. What is it? Ah, it was just like that. Okay, okay. Let me call that data, right? And we have this estimation. But when you have these numbers, I believe you can. Why do I have 1794? What was the answer here? Ah, 179400. Do you guys see the Excel?
Yeah.
If you click here, see how many decimals do you have?
Yeah.
If you click here, do you see how many decimals do we have?
Yeah.
Let's take let's take this number. I'm just curious. Let's take this number, and I will write it here instead of.
Is that what you're plugging into RStudio?
Yeah, because I'm interested. So this is.
Okay.
Um,
Yeah, that might work.
I'm not sure, but let's see. 6, 10, 11, 7, 7. Okay. This is too much. Here. So many decimals. And this will be here. But we don't have these numbers yet, guys, right? So because as you know, here, these are wrong.
Yeah.
These numbers are wrong. We have to have them as well. But
Professor, we don't see your RStudio.
oh, really?
Yeah.
Now you do, right?
Yeah.
So what I did is that, guys, I just plugged this number, right? Because why? Because this is 610.11.11.7, and it goes on, right? But in R, I just hit this 16.12. Okay. Let me see. I'm not sure if I get the right answer. I mean, that was right before, but whatever they want us to have. And no, right? So because
It's still off. That's
still,
crazy.
yeah, so that means we have to calculate, we have to use this formula. Do you see what I mean? We need to have these estimated standard deviations, guys. So how do we do it? So what is our X? Our X is, where is the Excel file? Our X is height, our Y is earnings. And what we need to do is that, do you see both, like Excel file and the formula that we have?
Yeah.
Good. So first we need to calculate X bar, right? So I will call this X bar. X bar will be just average of height, right? Average of height. That's X bar. X bar. And then we need to calculate X minus Xi minus X bar. So I will call this column Xi minus X bar. So which is Xi is this one, and then minus X bar, but then we have to put dollar signs here because I have to fix that value. because then I will be able to double click here and I will get all these numbers, which will be hopefully good. Let's see. So this is like 60 minus that, which is good. Correct. So then guys, so now I did xi minus x bar part, right? Then I have to take it to the second power. Then I will be doing like this, xi minus x bar to the second power, which is this is equal to this to the second power. So, and then you can double click and then you'll get this. So you have this, right? But then we have to calculate u hat, right? First, because we have u hat here. How do we do it? For that, we need these values, right? We need that values. And we need to use those values. Okay, great. So we have these two values. This is, guys, remember, this is beta 0 hat. And this is beta 1 hat. So what will be u hat, guys? U hat. Let me make a column here. U hat for every observation I. Okay. UI hat. That will be what? What is y? What is y? What is UI hat? This is yi minus yi hat, right? UI hat is yi minus yi hat. What is yi? Yi is earnings, right? Guys, are you with me? Yi is earnings, so
Yes.
that's yi. And then we need to subtract yi hat. But yi hat is what? Can you tell me? Beta 0 hat plus beta 1 hat times xi, right? But xi is this, right? 59 in this case. Close the parentheses. But we need to fix those numbers for every value down. So that's why we need to put dollar signs here. And also you have to do both dollar signs for this. And that's it. So now you can click on that and then double click and then you get these numbers. Double check. So what we have here is this blue minus this magenta plus violet times B15, which is that. Great, so that's good. So now we have U hat I, right? So good. Now let me insert a different column. Then what do we need? We need to raise U hat I to the second power. UI hat to the second power. And that will be equals UI hat raised to the second power. And that's what we have here. Then let me insert more column. And then you multiply, this xi minus x bar squared. Do I have it here? Yes, I have it here. Then I will how can I do it? This one. This one. Multiplied by that one. And this will be z multiplied by this, which is that. Okay, so see, this is a lot of hurdle, but I mean, that's how it is done. Or I mean, that's because they want us to be precise up to the third decimal. And in R, we are getting answers that are precise up to the second decimal. And then are we done? In the numerator, we need to sum all of this, right, Jahid? And okay, let me call that, let me create a new column. Oh, I need to do this. Now let me create a new column where I will say numerator sum. I will call this numerator sum, and this equals to sum all these values. All these values, close parentheses here, and is equal to that. That's the numerator. That's this part. And we then need to multiply these. And now I will call this numerator. Okay, sorry, I have to insert a new column.
Or n is 100, right?
N is 100, as I remember. Oh, Mattia, it's you. So n is 100. And so then we will have what? So equals this. Okay, let me do this. 1 over 100 times 1 over and then 100 minus 2, and then times the sum that we have here. And that's our numerator. That's our numerator. Okay, that's the number. And then we have to now calculate the denominator. See. To calculate denominator, we already have the sum xi minus x bar squared. Do I have the sum for that? Xi minus, no, I don't have a sum for that. Let's do it. Let me call that denominator.
Wait, isn't the sum same? It's xi minus x bar.
Yeah, but that's not the sum. That is just for every observation. Now we have to sum it up. Xi minus x bar squared. You are saying, oh, what did I do? Sorry, I think I'm not sure what I did, but so here you are talking about this, right? We have xi minus x bar squared for every observation, but we need to sum for every observation, I from 1 to n, right? So because of that, we need to do n sum, and then we sum these values up. Close parentheses, and that's the sum that we have here, but that's not enough, right? Because we are left with what?
Multiply with 1 over n.
Exactly. So we have to do the following. First equals parentheses to the second power. And then we will have to do times the sum that we have here. But then we also need to do 1 over 100. So that's how it is done. So that's this, right? But then why is it so small? Oh, yeah. I'm not sure. So, okay, but that's already squared. Okay, and then the sigma hat, sigma standard deviation, right? Estimated standard deviation of beta 1 hat or beta hat 1. How did I have beta hat
Here
1?
it just says beta 1. It doesn't have hat.
It should have, that's a typo. That's their typo. Will be
Yeah, because the standard deviation is with hat.
exactly. But it also should have hat here. So it has to have two hats, sigma hat and then beta hat. Equals, what is our numerator? Z divided by denominator, which is this. Okay, so what's going on?
You just misclicked on that wrong.
This one divided by that one. Okay, and then we have to take square root of it, right? Because that's the variance and the standard deviation. That's the estimated variance. And the estimated standard deviation will be equals square root of this, which is 784.19. Let's see what do we have in R. See, Mattia?
Yeah, it's literally the same, just has a few extra digits.
A few extra digits. So, but that a few extra digits probably are doing their job. Do you see what I mean? So, okay, so
Go through
this,
so much just to get those few extra digits.
you need so much, you
To
need to
sort of program R to round to like 3 or 4 digits.
yeah.
Shall we select? Is it possible?
No, I mean, I'm telling you guys, this is like a lot of hard work for nothing because R is already giving you right answers. Do you see what I mean? That's for the third decimal. But I mean, if you're right up to the second decimal, then it's fine. Do you see what I mean? Why do I need to care about the third decimal in this kind of problems? Sometimes it is really important, but in this kind of problems, no. Now let's see what's the confidence interval. What will be the confidence interval? CI, 95% CI. I just wanted to show you guys that, you know, this is how you do it, right? It's not like, it's not difficult, but it's time consuming, right? That's fine because you practice. That's the beta hat 1, right? And then minus 1.96. I do not agree with 1.96 because the sample size is less than 120, but whatever. Pearson is programmed that way. And then that's the answer. I think that's the answer the Pearson has. Do you see?
It has 926.899.
Which is exactly this one, but the thing is we are even more precise. Do you see now? Like now we even have the fourth decimal. Yeah, that's how it is. So what would you say? I mean, I will upload this on the CUNY Blackboard and you will have this recording as well. But I mean, in your exercises, the numbers will be different. You will have to do this on yourselves. But are we, so, but the thing is, whatever we have here, what did we have here? So we had here, okay, let me copy this. We did this one, minus 1.96, and that's 784.19. Let me copy this and paste it here, then plus here, and then you get these numbers. Let me say just one. 90, 89, and then we are missing, like we are off from the third decimal. But I mean, I hope you guys understand. So I also, so we did it in Excel as well. I already told you how to do it so that you get the right answer. You have to just follow the hints the person gives you. Does not mean that whatever you do in R is wrong. It's good, but it's correct up until only the second decimal, because you don't have these values here with, so those values only have two decimals. That's it. So if I am clear and if everything is like clear, then let me please go on. But do you have any questions up until now?
No, but I am wondering, like, we did certain number of calculations in Excel. Like, could we sort of do combination of the two? So, like, when we reach, like,
No. So that's what I said, Mattia, that there's no built-in function in Excel that gives you heteroscedasticity, robust, standard error. So you have to go over all these steps. There's no way.
I see, I know. But I'm saying, like, if we would copy those numbers in R, then it would give us exactly.
I see. Yeah. So this is like a program. It's like already programmed. If you copy the numbers in these columns, right, then that will give you answer here.
I see.
But do you see what? But the thing is, you will have to change these numbers. Do you see why?
Yeah, because when we calculated like UI hat and all of those, they had more.
No, you just have different estimates, right? So you will have different numbers here. You will have different beta 0 head, beta 1 head. So that is because of that, you will have to change this.
Yeah, no, I'm saying in that problem, like once we calculated these, I'm not saying like that my problem has different numbers or all of that, but like as you are doing that, once we reach those numbers, we can sort of copy them to R and then finish off calculations there, if it makes sense.
Yeah, you can do that. Yes, you can do that. But this is already a lot of hurdle. But that's what it is. Sometimes you cannot do anything. I mean, if in real life, you would not do this in Excel, right? So I mean, this would be enough. This number is fine. Like just off from the third decimal, but otherwise it's okay. Okay, so that's what is this. So now let me and then the next question is run a regression of earnings on height, but only for female workers. And that's, you do this using this command, right? Please take a look at this command to understand it, try to understand it, and just condition that I conditioned the gender for females. So it's like sex equals 0. This stands for female. Sex is a dummy variable here, and takes two values: 0 for females, 1 for men. And you run this model, and then gives us estimate. But all of these estimates are saved here, right? In this linear model females, which is the name I gave to the model. And then you can summarize, and then, but okay, these numbers are good, the estimate coefficients are okay, good, but the other numbers are wrong. Like, I mean, the estimate standard deviations are wrong, p-value, t-statistic, which is the same as t-statistic, and probably p-values, those are wrong. And then that's why you do coef test, HC1. And Good. So then you have these numbers, and then they ask you to construct 95% confidence interval for this slope. What would you do? You just copy these, which I have done. Okay, numbers are different because when you download the data, new data set, then you get the different numbers. This one minus, and then they want us to use 1.96, but that's wrong because like females, how many females do we have? We have even less than 100. How can you use, in total, we have 100 individuals. Sorry, and then we have less females and less males, so 1.96 is bad. You shouldn't be using this, but whatever. So this is how Pearson is done. And then let's see what we get. See, we are again off. Do you see, Mattia?
Yeah, again, last digits. I mean, it's
yeah.
more often.
So in this problem, like this problem is not difficult, but I mean, you will have to, if you want to get credits for this problem, then you will have to do this in Excel because R gives slightly of answers. Am I clear? If that's clear, then I will just do the next problem, okay? Which is chapter 6, exercise 1. Okay, so I think I will, let me save this here and then I will upload this in the Kini Blackboard this evening. And now let's do 6.1. Did you try to do this before?
I was trying to do empirical questions that came under multiple choice ones because they somehow Pearson posted like each multiple choice question, multiple choice homework had like 2-3 empiricals as well.
Nice. So what do you see right now?
I see your R and then I see homework on the left.
6.1, right?
Yes.
Good, perfect. So again, this is not difficult, but let's go over it. First, we are starting a new problem. So because of that, I do not want to have anything here, right? I'm saying here in the environment window. So because of that, I will just start by this command line, which is just clearing the environment. Now let's download the data set first, which is here. And this, I think it goes here, college distance. Okay, so the data set is there, but the thing is we have to check the extension of it. So it can be XLSX, or it can be XLS. In this case, it appears the extension is XLS. It's not XLSX. The extension, I'm not sure what you are seeing, but just right click on properties, you will see right click on the Excel file, and then you'll see that the extension is XLS. And so that's important because, okay, so it's important because here I have to indicate XLS. You see the blue screen, right? I'm not writing XLSX because that would mess up things. So because the extension is XLS, not XLSX. Okay, so let me open data. I named it as data growth, and then let me view. Let's view this. Oh, what's going on? Data growth not found, but why? Oh, it's not growth. It's okay. So this we are not doing 6.1. We did it before. We are doing 6.2. Sorry, guys. 6.
I see, I see.
So I have to download this growth. That's why. So we now have growth here, and I will open this data set. So what was the extension for that? I don't remember. Let me see. It's again XLSX. Good. So then, okay, let me click on my command line 65. It will clear the environment window, and then open Excel in R. That's what it does. And then view, and then we have all these columns, and of course you have to check, do I have the last row right and everything, and there's we had, and I double checked everything and everything is fine. But I mean, when you open the data, you need to check that, you know, is everything good? Is the data open properly? Because if it's missing certain, like the last row, for example, is sometimes missing because if you don't indicate extension properly, something like that. So at least look at the first row and look at the second. Sorry, look at the last row. At least. Okay, so then the first question is obtain the mean standard deviation of for growth, trade year schooling, all these variables. Okay, so how do we do it? So we do it like this: mean data growth, $, RGDP 60. RGDP 60 is the variable there, and that's the mean. If I wanted to get the mean of a different variable, which is in this data growth, I would write $, and then I would pick whatever variable I want to, whatever variable I am considering. So in this case, it was before it was RGDP 60, but maybe I'm interested, what is the mean of trade share? Or what is the mean of whatever, oil, right? So trade share, for example, and you can do it, right? So, okay, it gives you the mean. Similarly, you can calculate standard deviation. The function is ST, and similarly, you can calculate standard deviation for that variable or any other variable. Okay, so the mean is, what's the mean? RTTP, what's the mean for RTTP? What is the, let's see in Excel, something is, let me share Excel screen with you. Equals, oh, I have to make, okay, share. And now let's calculate mean. Not sure what's going on. Average and RGDP 60, which is here. The mean is, that's the mean. Do you see, Mattia?
Yeah, I see it. I'm trying to, it won't let me open the growth in R. So once we download it, we just go and run. Do we need to open it within R?
Did you set a directory?
I did. I said the directory.
Okay, now let me see what's going on here. This is exactly what we have, right? So R gave us this mean, right? Which is exactly what we have in Excel.
Yeah.
So that means Pearson is, there's a typo again in Pearson. Because the right answer here is according to Pearson, it's 2513, which is incorrect. So it should be if you round up, it should be like closest this one, right?
3103. Yeah.
Yeah, that's the closest. Okay, so the good thing is you won't get these empirical problems in the exam. So unfortunately, there are certain typos. Now regress growth and trade share, years of schooling, and then certain other variables. That's what I do here. Like this growth is the dependent variable. Then we have independent variables, but they enter with plus. Do you see that there? So these variables enter with plus. It means that we have different independent variables. And but where is the variables? It is in the data set, which we named as data growth. Okay? It is just a syntax. It will be great if you get familiar with the syntax and with the others too. And okay, all the estimations are saved there, and then we will just summarize. And then this is the summary, and okay, what is it? So the coefficient estimates are good, but the standard deviations are wrong. So now the next question is, interpret the coefficient on years school holding the other variables constant. Years school is here. And you need to know what's the units of measurement for the dependent variable and for this independent variable, which is in this case years of schooling. Years of schooling is measured in years. So it seems like that every one additional year of completed adult schooling increases the average annual growth rate by 0.58 percentage points.
So that means that this estimate in R, that everything is in actual percentages.
Yeah, that's what it means. Growth is in percent. It's a percent growth, not in logarithms. It's just, the growth just is in percent. Growth, it's a growth rate measured in percent. So an additional year, this is not even like precise, like this is 0.58. This is 0.5748. Do you see?
Yeah.
For the cloud, about
maybe 0.57 more accurate if they're rounding.
Yeah, true. Yeah. Okay. Is the coefficient on year school large or small? It's a very subjective question. So, they want to take this answer. Okay, that's fine. It will be more like intuitive if you ask, like, is this coefficient significant? Okay, so what would you say if I ask you that? Is the coefficient in front of years of schooling significant in statistical sense? Can you tell me from this?
I that's in one of the previous classes. That's like if it's, we have to take into consideration two things, not just one.
Yeah, but that's if you are saying, if you are answering question, is it important? Is it large? Something like that. But I'm just simply asking, can we, based on this estimated estimation results, say whether the coefficient in front of years of schooling is significant or in statistical sense?
I think that what Pearson does is like the moment it's above, if it's not 0, it is significant.
No, it is like, if you need to take a look at the t-statistic, which is 4.1126, this is like, this is bigger than the critical value, even at like 10%, which is is bigger than any critical value. Like 10% is what? 1.645. 5% two-sided. 5% is what? 1.96. 1% is what? 2.58. 2.58, as I remember. Yeah, so this is like bigger, this number here, this statistic is bigger than even 2.5. It is even significant at 1%. And the p-value also indicates that, because p-value is less than, in this case, what? 0.01. So it is, but the thing is, we cannot really say that, because, as I said, these numbers, these estimated standard deviations are not correct, because we did not correct for the heteroscedasticity, the disturbance term. So we had to use this command line 95 to obtain, did I do linear model tree not found? Right. Okay, then first we have to run this. And then I do coef test. What's that? Okay, use this, use this data set, and then linear model tree, and it runs it. And then if you do coef test, it should give us these numbers, right? So, and you have all these estimated standard deviations, and they are good. And then you can make, like, you can then test hypotheses. But I think this is for a different question. You could do the same thing, coef test, for this model as well, right? Not just summary. So I think I'll do this, and then I will close today's office hour and then continue maybe next week. I will just say this, that this coef test goes here. And so linear model, summary of the linear model. Okay. And oh my God, I think I went down. I was doing exercise 1, right? And then suddenly I am at exercise.
Yeah, because exercise 1 is 6.2 and exercise 2 is 6.1. So that's why it was a little confusing.
Yeah, so
I think we started one and just ended up on the other one.
Yeah, so I'm sorry. So we are doing this one, right? So we are doing this. Yeah, you're right. So mean and standard deviation. Good. And then you run this linear model, and then you do summary, and then you have these years of schooling. Now we have it, right? So this coefficient is good, but this estimated standard deviation is wrong. It's not correct because of the heteroscedasticity. You have to use coef test function, which I will do right now, to obtain heteroscedasticity robust standard errors. It's just linear model, right? So we don't have three for different questions. This is not even, this is LM growth. That's the name of it. So I have to make correction here. and run. So now if you see, we see that this number here will be different from what it was here. See, here was 0.1393379, here is 0.1228. So this is correct because this is already corrected for heteroscedasticity in the disturbance star. And now we can talk about whether the coefficient in front of years in school is significant or not. So for that, you will take a look at the test statistic, which is 4.6809. It is higher than even the critical value at 1%, which is 2.58. So therefore, yes, the coefficient in front of years of schooling is significant, 1%. And that is also shown by this p-value, which is really small, much smaller than 1% for 0.01. Okay, so what I will do, Mattia, is that I will upload this code once again on the CUNY Blackboard. There are other examples too. You may find this code useful. And I will also have like some additional office hour for these empirical questions, guys. But for now, I think I will close today's office hour. But do you have any particular question?
Well, I wasn't able really to follow the first one when you did, when Jahid was here as well, so I have to redo that by myself. But this second one for chapter 6 is really like self-explanatory and makes sense.
Yeah. So please,
numbers align as well, so we don't even have to go back to Excel. The first one was like completely off.
Yeah, it was not. I mean, I would say it was off from the third decimal, right? No.
Yeah. I mean, for the results, Pearson wouldn't take any of them, so that was.
Wouldn't take because our results, like the R results, were like did not have the third decimal.
Yeah.
Okay. So I will upload. So this office hour is being recorded, and I will download this, and like I will be able to do this like in a few hours, I think, and upload the link on the CUNY Blackboard so that you will be able to take a look at the first problem once again, because because we did step by step everything in R and in Excel, right? So I think if you take a look at it, because I mean, finally Excel gives you the right answers, the answers that Pearson wants to take, but it's time consuming, and I agree with that. Okay, so what else? Do you want me to do something? I mean, I think today I will close today's office hour, but I mean, if you have any particular questions, I will still be happy to answer.
Not about this.
Okay, so about what? Do you have any questions from chapter 7 or chapter 8?
There were a few things that I wasn't too sure about, but I also want to kind of reference back to the textbook. I'm not like really, for chapter 7 and 8, I didn't really do all of the work. So maybe next week, once you do office hour, might be better, so I come to you like actually ready with these questions.
Yeah, so Mattia, you were talking about empirical questions or analytical questions?
No, not empirical. Cool, that's why I was like, it's not related to the office hour or any of that.
I see. So the thing is, so the next week, I will only be doing analytical problems from chapter 7, 8, and also we already did chapter 6, but still maybe I have time to do chapter 6 problems once again. But definitely I'll do problems from chapter 7 and 8.
Oh, perfect then. Yeah. So I will come back to you with questions after you do all of that, so I don't make you.
Exactly. So, and also I'm thinking, I have office hours on a Monday, Wednesday. Okay. But I will also have one more office hour for empirical questions. And I mean, these codes, guys, should give you like many good intuitions, and this should be helpful if you really go over it and like try to understand it. But even if you do, sometimes you still have the answers which are like slightly different from what Pearson has, and that's because Pearson wants you to do like using Excel. Okay, which is like I mean, in real life, whatever you get in R is fine, it's good. But I mean, if you want to get the right answers that Pearson takes and to get the credit for that problems, you have to follow Pearson. That's bad, but that's how it is. I mean, if this was not like, I mean, it's also very difficult to like have when you know that you are doing everything right and you are like off from the third decimal, it is somewhat irritating. But I cannot change it. See, that is how it is programmed in Pearson. That is something I cannot change.
That's also unusual because I know that for some other problems, Pearson had like the error range.
Oh, really? Maybe,
Yeah, for some
maybe
problems. For some problems, I would input the numbers and they would be off by 0.001, but then it would like show me the correct answer and it would allow for like 0.2 higher or lower, but that was only for a few questions. And then for the others or like on exams, it doesn't allow for any error.
I see. So you are safer if you have the like exact correct answer.
Yeah, which is from Excel.
I see. But I also have office hour, which is like if I see that your answer is off from beginning. I think I had that policy before, that if you are off beginning from the third decimal, then you are fine. I will give you points manually, right? I mean, which means that you can still use R if you have to use it. But for the exam questions, you will not have to use R because I will not have empirical questions in the exam. Yeah, that's how it is in Pearson, but we cannot change it. But you still can get the right answers if you do what they want us to do. Like, I mean, the thing is, you have to use Excel and do all of the calculations yourself manually, like we did before today. Okay, so thank you very much for being here, Matea, and I will, when it is ready, I will upload the link of today's class on the CUNY Blackboard. And if you have any questions, just email me, and I'll try to respond in a timely manner. And on Monday, Wednesday, we have classes where I will do analytical problems from chapter 7 and chapter 8, very likely from chapter 6 as well. And I will have office hours on Monday, Wednesday before classes too. And then I may have office hour on Friday as well for empirical questions. Also, I want to like if others listen to this, if others see this recording too, please attend classes. That will be my request. Okay, so Mattia, have a nice day, and hopefully you found this office hour somewhat helpful. And if you have any questions, just let me know by email.
No, I definitely did. Thank you so much for Professor. And I know this is like really you going out of your way and holding extra hours, but it does help. And especially like, even though we don't need it in class now for exam, it does make sort of like once I understand how R works, that's the only time that I actually understand the actual material and what it's trying to get me to do. Excel sometimes gets me a little lost and like I find myself wondering like, why am I doing this? What is this?
Yeah, but this will be also should be useful in the future, guys. You will have to like have some experience in coding in R and Python. I'm not sure if I'll have time to do some Python because this is really like kind of time consuming, but it is a worthwhile labor, I would say. It's a worthwhile effort because it will, I think, pay off because these analytical skills, and if you are able to do stuff in R and in Python, I think is useful for future. Okay, thank you very much. Have a nice day and enjoy the weekend as well, because I think today is Friday, so we have Saturday, Sunday. So enjoy the weekend and hope to see you and others in class on Monday. Bye.
Thank you, Professor.
No problem. Bye, guys. Bye.